Hello everyone. Okay, so in this video we're going to be going over problems involving rates of flow. So what is rates of flow? So rates of flow is a measure of the volume of a liquid that passes through a pipe or a container per second. So like for example, water will come out of a tap at 10 centimeters cubed per second. So for every second 10 centimeters cubed of water is shoved through that pipe. Or you could say the rate of flow is 5 liters per hour, right? So every hour, 5 liters of water go through a pipe, right? That doesn't seem realistic, but you get the point, right? So that's what rates of flow is. And when we are solving questions involving rates of flow. So we're given two things with rates of flow. So we're given a flow speed, and this will help tell us what the rate of flow will be. So the flow speed through the pipe equals the height or length of the column of water for the pipe for that particular time period. So a flow speed of 12 centimeters per second in a cylindrical pipe means that for every second, the flow of water travels a distance of 12 centimeters. So what's that mean? So I have a pipe here. This pipe is now a little snapshot of 1 second, right? So this blue part is a snapshot of 1 second. So after 1 second, water travels 12 centimeters in my pipe. And now all I need to do to calculate my rate of flow is the area of the cross section times the speed, or just simply calculate the volume of the cylinder. And if I calculate the volume of the cylinder after 1 second, that will give me how much water is shoved through in 1 second. So see all this blue? That's water, right? So after 1 second, it travels 12 centimeters. Now I calculate that volume there. So water flows through a cylindrical pipe with a radius 2 centimeters at a rate 25 centimeters per second. What is the volume of water that flows through the pipe in 1 minute? So I drew out a little diagram here. So this is a pipe. Water flows at a rate of 25 centimeters per second. So every second it moves 25 meters through my pipe. So again, remember, this is a snapshot of 1 second, right? So here's my pipe after 1 second, right? It's filled with water. It has traveled 25 centimeters. So I want to find how much water is in this pipe in that particular second. And that tells me the volume of water that is being shoved through the pipe per second. So the radius of this pipe is 2. And then the speed it gave me, the 25 meters per second or centimeters per second, gives me the length of my pipe after 1 second. So let's calculate the volume of the pipe after 1 second. So it's just going to be the volume of the cylinder, which is just pi r squared h. The volume is going to equal pi times 2 squared times 25. The volume is going to equal 100 pi centimeters cubed. So the rate of flow is going to be 100 pi centimeters cubed per second. So for every second, 100 pi centimeters cubed of water is rushing through that pipe. Every second, 100 pi centimeters cubed of water is rushing through the pipe. Right, but that's what the question asks. The question asks us here, the pipe after 1 minute. So how much water flows through the pipe after 1 minute? Well, if after 1 second it's 100 pi centimeters cubed per second, what's 1 minute? Well, 1 minute, if you recall, is equal to 60 seconds. So I just multiply this answer by 60. So after 1 minute, it's going to be 100 pi times 60, which is going to be 6,000 pi centimeters cubed after 1 minute. So that is how much water is being shoved through the pipe after 1 minute, which is, so it would be 6,000 pi centimeters cubed per minute, right? So that is an example of rates of flow. Let's do another one here. Oil flows through a circular pipeline at of a radius 4 centimeters at a rate of 20 centimeters per second. How long will it take to fill a cylindrical tank of a diameter 1.2 meters and a height of 3 meters? Give your answer in minutes. So, it's always important doing questions like this. Sketch it out. Sketch it out. Draw it out. What are you looking for? What is the question asking? Draw it out. So, I have a pipe. This is the pipe my oil is flowing through. Now, I'm now an artist, right? There's the pipe the water's flowing through. So after 1 second, the oil has travelled 20 centimeters. Right, so the oil has travelled 20 centimeters after 1 second. So let's find the rate of flow here. And then the radius here is 4 centimeters. So what's happening here is I have a cylindrical pipe here, or a cylindrical tank, I should say. And this is collecting the oil that's falling out. So the oil is coming out here and filling up this tank. So I want to find out how long will it take for it to fill up the tank. So that's where I need to find my rate of flow. So if I'm a rate of flow and I find like 5 liters per second, I can then use that to find out how long it will take to fill up this cylinder. So let's find my rate of flow here. So my rate of flow, or F, rate of flow, is going to be, so it's going to be the area of the cylinder after 1 second. So it's going to be pi r squared h, where it's going to be pi times 4 squared times 20. So it's going to be 320 pi centimeters cubed per second. So it is, water is running out of this pipe at 300 pi centimeters cubed per second. So for every second that passes, 320 pi centimeters cubes of water rushes out of this pipe. Now all this oil is filling up this cylinder. So I want to find out how long it takes to fill up this cylinder. So let's just find the volume of the cylinder. So again, pi r squared h. My radius of the cylinder is given to me as 1.2 meters. So 1.2 meters and a height of 3 meters. So I have a diameter of 1.2 meters. So I have meters here. My rate of flow is in centimeters. Kind of want them to be in the same unit, so I'm going to convert these meters into centimeters. So 1.2 meters is my diameter. So that means my radius is going to be 60 centimeters. So half of that. And then my height is going to be 300. So it's going to be pi times 60 squared times 300. 60 squared times 300. So that's going to be, oh gosh, a million. Ooh, right. 1080000 pi centimeters cubed. So that is how much oil this container can hold. So, and then there is my rate of flow. So I know it flows in 320 pi centimeters cubed per second. I need to fill 1,080,000 pi. So let's figure out how long it will take. So if every second 320 pi goes in, so let's find out how many seconds it will take. So it'll be 1,080,000 pi divided by 320 pi. And I'm going to get 3,375 seconds. But in the question, what's asked for? Give our answer in minutes. So how do I convert seconds into minutes? I just divide by 60. So I'm going to divide by 60. And then I'm going to get 56.25 minutes. And that is how long it will take to fill up that bottom container if my calculations are correct. Right? So let's look at one more question now. A cylindrical pipe with a radius 5 centimeters is filled with water to a height of 20 centimeters. If the water flows out the pipe at a rate of 4 centimeters cubed per second, how long will it take for the pipe to be empty? So I have my pipe here. Let me just draw it out. Again, always important to sketch. So 20 in the radius of 5. So water, it's filled with water. Yeah. Now, obviously, there must be a little pinhole in it or something, or they must be releasing it from the bottom. Maybe they're releasing, have a little hole at the bottom here. And water is flowing out of here, right? At a rate of 4 centimeters cubed per second. So we want to find out now how long will it take for it to be empty. So we'll find the total volume of the pipe. So the volume of the pipe is going to be pi r squared h, which is pi times 5 squared times 20, which is going to be 500 pi centimeters cubed. So that is how much water is in the tank, and I'm losing 4 centimeters cubed per second. So that is going to be 500 pi divided by 4. That's going to give me 125 pi seconds. I'm going to change that. So that's going to give me 392.7 seconds. And which is roughly going to be equal to, do we need to do minutes? Nah. But if I want to do minutes, divide by 60, I have 6.5 minutes roughly. Right, so it's going to take around 392 seconds or around 6.5 minutes to fully empty out of the pipe. So again, as I said, there's 500 pi centimeters cubed of water in the tank. And then I'm losing 4 centimeters cubed per second. So I want to find out after how many seconds I have nothing left. And that's kind of some basic questions on rates of flow. I hope it was some use to you, and I'll catch you later. Bye.